Hi students, MCQ number 9. An ideal gas is taken through the cycle A to B, B to C, again C to A as shown in the figure. If the net heat supplied to the gas in the cyclic process is 5 joule, the work done by the gas in the process C to A, only C to A, how much work is done we have to find out. It's a very good question, very interesting question based on this graph. So it is a PV diagram. Pressure is taken along the x-axis and volume is taken along the y-axis. You can see the points A, B and C at the vertices of a triangle. Okay. Now from the first law of thermodynamics, the quantity of heat supplied delta Q must be equal to the change in the internal energy of the system plus the work done by the system. Okay. Now you see here the system started from A and returned back to A itself. So in a cyclic process, okay, delta U, change in internal energy, is equal to 0 for a cyclic process. So in this equation delta Q must be equal to delta W. But work is done in three steps. So A to B, then B to C, then C to A. Therefore, delta Q must be equal to work done from A to B plus work done from B to C plus work done from C to A. So work done from C to A we have to find out. Now there are three terms on the right hand side. First I will find out work done from A to B. Okay, work done. Now A to B, you see here A to B, the x-axis pressure remains the same. From A to B, pressure remains the same. So P into delta V. So the pressure remains the same and that is equal to how much? 10 into A to B. So what is the volume change? Volume is changing from 1 to 2, 1 meter cube to 2 meter cube. So pressure is 10 Newton per meter square I have written. Into delta V. Delta V is what? 2 minus 1. So this is 2 minus 1. So this is equal to 10 into, okay. So this is 10 into 1. This is equal to 10 joule. Because the general expression for the work done is what? P into dV. So here pressure is kept constant at 10 Newton per meter square. Volume changes from 1 meter cube to 2 meter cube. So change in volume is 2 minus 1. So this must be 10 joule. Okay, are you understanding the first step? Like that, now you try to find out WB to C. So WB to C. So this is equal to what? P into delta V. Okay. Now you see here the points P, the points B and C. They correspond to the same volume, is it not? Same volume 2. So the volume at B and C remains the same. Therefore, delta V must be equal to what? 0. So P into 0. Understand that? So WBC or WB to C is equal to 0. So you can see the total work done W, A to B we have found as 10 joule, B to C is 0. And the third term we have to find out. So I am going to substitute for delta Q. So here delta Q is given as how much? 5 joule. Okay. So the net heat supplied is equal to 5 joule is given. So I am going to substitute in this equation delta Q is equal to what? 5 joule. So 5 joule must be equal to W A to B is 10 joule. 10 plus W B to C is 0 plus W C to A. So what is asked here? The work done by the gas in the process C to A is only asked, is it not? So we have to find out W C to A. Therefore W C to A must be equal to what? 5 minus 10. So this is equal to minus 5 joule. Okay, this is the answer we have got. So option A itself is found to be correct. Therefore option A is the correct answer. So this type of diagrammatic questions will be very simple, provided if you have understood the concept. So here we are substituting in the first law of thermodynamics, and there are three terms because there are three steps involved in this work done, and each work done we have to determine and add on the right hand side. I hope you must have understood well. Fine.